Hello and welcome to SudoKanard. We're here to solve this Rossini Arrow Sudoku by Jan Vondruška. Once again, a puzzle from the Czech Championship. Jan Vondruška created well, a huge corpus of Sudoku memorable puzzles. And this one mixes Arrow Sudoku, in which the digit in the circle is the sum of all digits along the arrow, and Rossini. This arrow means that those three digits are ascending from the right to the left. This arrow means that those three digits are ascending from the left to the right. And this lack of arrow means that none of the two applies here. So this digit is either bigger than those two or lower than those two. This is what is happening in this puzzle. You have a solving link in the description so that you can try it before watching this video. If I recall correctly, my solving time was 11 minutes when I test solved the puzzle, and it took a little time to find the break-in. And if I recall correctly, the breaking is somewhere around here. Because those arrows here tell us a lot. This can't be too low. This can't be too low either. So this sum here is biggish, but it can't be too big because of this arrow. So what can we do with that? If we try to have something like 1, 2, 3, then this would be 4, 5. That's the minimum. If I try a 3 here, then the minimum option is this, and then the minimum option is this, in which case this is 8, but this arrow can't be satisfied. So putting a 3 here would make the sum too big. So 3 here doesn't work. If I try to make this 4, then we have something like this. And then the minimum value here will be 5, because this would be a minimum of somewhere in 1, 2, 3, and this would be 5, which means that this would be 9, and there again, this arrow would break. So that this here is at least 5, and because of this arrow, this is at least 2, which means that this is at least 7. But because of this arrow, this is also at most 7. So that we know that this has to be 7. And because this had a maximum of 2 and this had a maximum of 5, it means that this is a 2, this is a 5. This now has to be 1, and those have to be 3 and 4. How cool is that? This is really a remarkable breaking. And now to satisfy this clue, this has to be 8 and this has to be 9. Amazing. All right, so now these 3 digits are not here, so they must be in this area, and it shows that 9 is somewhere here. Now those arrows tell us that 9 is somewhere inside those cells, which prevents 9 from being anywhere here. 9 won't ever be on an arrow, and it won't be here in the middle of this row. So that's a place for 9. 9 could be anywhere here. Now, where is our next place of interest? This can't be 7, 8, or 9, so this is at most 6. But with those 3 digits, the minimum value that you can make is 1, 2 plus 2 plus 3, which is 6. So that is 6, and this is a 1, 2, 3 triple. We can remove some options. And now what those are from 1, 2, 3, 4, 5. So this is from 1 and 2. This is from 3, 4, 5, and well, this is not worth pencil marking. And that's interesting. 6, 7, 8, 9 are all in this area. Now this is at least 6, so it has to be from 7, 8, 9. We don't know much about those digits at this point. 6 by Sudoku goes there. This is a 7, 8, 9 triple, and 8 can't be in the middle, because if 8 were in the middle, those digits would be ascending in one way or another, and there would be an arrow here. 9 is not here because it's there. Here we need digits from 1, 2, 3, 4, 5. And those 3 are ascending, so 1, 2, 3, 2, 3, 4, 3, 4, 5. And the two missing digits are here. One interesting point is that this digit is around here. So it can't be 3, 4, 5. So this is 1 or 2. Where should I look now? 6 is somewhere here. This digit is somewhere here, so this is from 7, 8, 9. Those 5 digits are ascending. I will use a thermometer here. 1, 2, 3, 4, 5. Not sure what to do with that. Oh, but we know that those, if I try 1, 2, 3, 4, 5, then those are minimum 6, 7. This is much too big. So that will never be a 3, because then that would be 1 and 2, and the sum would be at least 12. So it's the same kind of logic as in here. If I try to make this 4, then I use 2 digits from 1 to 3, so that one of the digits here has to be at least 5. That doesn't work. So this is at least 5, and at most 6, because 7 with a 7 on this arrow, that would be much too big. So this is 5 or 6. This is 6 or 7. This is 7 or 8. And now, so this is never a 7. Those are from 1 to 3. It could be 6, 1, and 2 for a sum of 9. It could be 5, 1, and 2 for a sum of 8, or 5, 1, and 3 for a sum of 9. And that's interesting, because we already have 2 of those digits around here. So only one of them could be there. And it's not even necessary. We could have 4, 5, 6, or 1, 2, 3, 4, or 5. So in both cases, this is from 4, 5. And 9 is somewhere here. Well, what else can we do? This 4, or 4 can only be here. It couldn't be there because it would be impossible to have an ascending sequence with 4 in one of those corners. Now this is smaller than that. We are left with 5, 6, 7, 8. So this is from 5, 6, 7. This is from 6, 7, 8. And here we just know it can't be ascending from top to bottom, so this has to be bigger than that. Like instead of using a thermometer, I will just mark the candidates. Right. Now, where is 9 in this area? Well, definitely not here. So it won't be here. So 9 will be somewhere here. And that's interesting because now in this area, 9 has to be there. But then what else can be found at this point? I don't know what can be found. I don't think much can be done with this arrow. This can't be too big because of this, but it could still be as high as 7. Note that the minimum value here is 3, so this could be as low as 4. Somewhere between 4 and 7, this is not very useful. Note that this digit here is somewhere in there, but this is at least 4. So this digit is not in here, it's there. So 1 or 2, it could be 1 and 2 here, but this is 1 or 2. And that's interesting because now 1 and 2 are not here, so this is at least 3. All digits here are at least 3. So that those 2 digits are in this area. We could have 1 and 2 here, we could have 1 and 2 there. But in this area, the smallest digit is here, so that's 1. And 2 could be here, or it could be there. And this digit is not here, so it has to appear somewhere out there, but we don't have an arrow, so we don't know which position this digit takes. I was much quicker when I did the test solving, so there is something that I saw this time that I'm not seeing. Those are from 1, 2, 3, 4, 5. Yes, 6, 7, 8, etc. are in here. Only 2 of them are in here, at most. So 2 of them at least must be there. And they will be, so that at least 2 digits from 6, 7, 8, 9 are in here, so they must be at the end. This is from 6, 7, 8, this is from 7, 8, 9. And at least 1 of them is in here. They can't, all 4 of them can't be here, so this is from 6, 7, 8, 9. I will use heavy pencil marking, I'm afraid. Oh, I've been missing this. This is not a 9. So 9 is here in this area, so this is not 9. This is not 8, and this is 9. And the third digit from 6, 7, 8 can still be here, it can still be here. Nine can be anywhere in there. It could be here. No, no, I was about to say something wrong. Not sure what to look for. Here we have 3 ascending digits. Oh, and the second one of 3 on the row has to be here. The remaining one of 3 is the only digit that can go there. And those digits are the 2 missing digits from 5, 6, 7, 8, 9. So this is from 5, 6, 7. And 7 won't work here because this has to be bigger. So this is from 5 and 6. And this is not 7. This is from 6, 8, 9. And this is not 9 or 8, so this is from 6 and 7. And this is smaller than 6. So it has to be from 1, 2, and 5. Again, I'm not sure how useful this is going to be. Except that 7 on this row can only be here. So that this is 8, this is 6, and this is 5, because this has to be ascending. This is 7, this is 8, 9, 7. So a lot is happening all of a sudden. This is 6, this is 9. Goes out from 2, 3, 4. And at the bottom, we need 8 somewhere. I don't think I can do much more, or anything more for that matter. But now, we have placed lots of digits around here. This can't be too big now. I said that it has to be at least 4, so this is from 4, 5, 6. And this can't be more than 5, so this is from 3, 4, 5. And the ascending character here tells us that this can't be a 3. This is from 3 and 4. So we get a 3, 4, 5 triple. The remaining digits are 7, 8, 9. Here we get a 7, 8, 9 triple. We get one here as well. So this is 6. This is not 6. So this as the sum of both digits here. So that can't be a 5 anymore. This is a 4. This is 1. This is 5. That's the only way. That is 3. This is 2. This is 5. Here we need 3 and 4. This is 5. This is from 1 and 2. So some progress has been done then. Here we need digits from 6, 7, 8, 9. And this here is not a 9. 5 here. So this is 4. This is 6. So the only way to satisfy this is to add 1 and 2 for a total of 9. Now this is 9. 9 is not here. And 6 is not here. And 7 can't be in the middle, because those would be ascending in some order, and actually 7 is here. 3 is here because of this thermal. This is 5. this is not 2 anymore, 2 is there. This is 7 or 8, and this is 9. 3 must go here, 8 must be here, so 6, 7, 8, 7 here, 8 there, 2 here, 1, 3, 2, 1 and 2, 7, 8, a lot is unfolding. This now can only be a 4, that is 3, this is 1. This can only be 8, this is from 2 and 5, but those are not ascending, so that 2 is in the middle. Here I need 5 and 3, so this is 5, this is 4, this is 3, here I need 1 and 2. This column needs a 4, that is 6, and this is fulfilling, this arrow is now fulfilled. Here I need 1, 3, and 4, so 1, 4, and 3, and now 4, 5, and 6, and this is it. So it was a kind of struggle. All the steps were completely logical, very, very nice setup again. But my vision was not on top. Well, I hope my explanations were. Thanks for watching this video. See you soon on SudoKanard.